All right, guys, so we are going to be picking up our notes from where we left off yesterday. We finished up parallel lines, and you guys should have started your class off today working through those parallel lines assignment that I gave you yesterday. So now we are looking at perpendicular lines. And perpendicular lines are two lines that intersect to form right angles. So their angle created is a 90-degree angle. And so if we look at the slope of the red line, we notice there's a point right here. We notice there's a point right here and a point right here. And that is down 1 and over 4. So our slope is -1 over 4. And now if we look at the blue line, we will notice that there is a point here and a point here. And that is up 4 over 1. So we notice that the slope of the blue line is 4 over 1. And we talked about opposite reciprocals yesterday. And what this tells us is that perpendicular lines have opposite reciprocal slopes. Or as Missy Elliott said, those slopes are flipped and reversed. So what is the slope of the perpendicular line of y equals 2 over x minus 8? For right now, we are just going to be looking at the slope. The slope of a perpendicular line, we would take that 2 over 5, and we would flip it and reverse it. So we get -5 over 2. The next one we have y equals -1 over 5x. Looking at this one, we would take that -1 over 5 and flip it and reverse it. So it becomes 5 over 1 or 5. The next one we have y equals -2x minus 7. We are flipping and reversing 2. When we flip -2 and reverse it, it becomes 1 over 2. So now we're going to find the equation in point-slope form. Again, that point-slope form is that y minus y1 equals m times x minus x1. So we're going to find the equation in point-slope form of the line that contains 0, -2, and is perpendicular to y equals 5x plus 3. First, we need to find the slope by going flipped and reverse of 5. So our slope of our new line is going to be -1 over 5. And now we are going to plug in our x1 and our y1 into this formula here with our new slope. So we end up with y plus 2 because the -2, the y minus -2 becomes a plus. And the -1 over 5x, we end up getting rid of those parentheses because -1 over 5 times 0 is just 0. So we do not need that extra point. Looking here, we're using that. Now we are trying to convert to slope-intercept form. So we will start in point-slope and convert to slope-intercept. So we first need to find the perpendicular slope. So this slope will be -4 over 3. And then we are going to plug in for our x1 and y1 into point-slope form, and we get y minus 8 equals -4 over 3 x minus 1. And then we are going to distribute that for over 3, and we are going to end up with y minus 8 equals negative 4 over 3 x plus 4 over 3. And now we are going to add that 8 we're going to keep that as a fraction over there. So we're going to end up with y equals negative 4 over 3 x plus an 8 as a fraction over 3, so we can add it to the 4 is 24 over 3. 24 plus 4 gives me 28 over 3. All right. So again, we're doing the same thing. We're putting it into slope-intercept form. We have our x1 of 2 and our y1 of negative 3. We first find the slope that is perpendicular. And our slope of our perpendicular line will be y equals 2. We then plug it into point slope form and get y plus 3. Since it's negative, negative and a negative becomes plus 3. We get 2x minus 2. And we distribute that 2x. We end up getting y plus 3 equals 2x minus 4. And we minus off the 3 from both sides. And we end up with a final answer of y equals 2x minus 7. So now looking here, we're trying to determine if the lines are perpendicular. And again, we are looking at this slope. And this one is not ready to be looking at the slope, so we have to work to find out what this one will be. So we end up subtracting the 2x from both sides. Just like we did yesterday with parallel lines. And we end up with 3y equals negative 2x plus 4. We divide the 3 from both sides on all 3 of our parts. And we end up with y equals negative 2 over 3x plus 4 over 3. We are looking to see if this one and this one are flipped and reversed. The original was 2 over 3, so the flipped and reversed of this should have been negative 3 over 2. We look here and we see that we don't have negative 3 over 2. We have negative 2 over 3, so these are not perpendicular. What they are is intersecting. They're intersecting. So now we look, and we'll try this next one. It says determine if the lines are perpendicular. So we're going to solve out for this one here. When we solve out, we get 4y plus 3x equals 9. We swing over the 3x, and it becomes minus 3x plus 9. Then we divide away the 4, and we get y equals negative 3 over 4x plus 9 over 4. We're looking at those two slopes. 4 over 3, the opposite reciprocal or flipped and reversed, should have been negative 3 over 4. That is what we have. So these two lines are perpendicular. Got a little challenge here for you. What is the slope of the line that is parallel to x equals 4? X equals 4 is an undefined slope. So the lines that are parallel to an x equals 4 are undefined for their slope. What is the slope of the line that is perpendicular to x equals 4? So parallel would have the same slope, which would be undefined for both of these. The flipped and reversed of undefined would actually be a slope of 0. So yesterday we talked about parallel lines, and we looked at how their slopes are what tells us if two lines are parallel. Slopes that are identical or congruent or the same are parallel. And we were able to write equations of parallel lines using a point and the slope of the parallel line. And then we did the same thing, but for perpendicular lines, determining if they were the opposite reciprocal slope, and then using that opposite reciprocal slope and the point that was given. There's an additional assignment that follows along for the perpendicular lines. That will be handed out when you finish the notes. Good luck, and I will see you on Wednesday. We will recap what these covered on Wednesday with me.